You know, we are absolutely swimming in data these days. Every organization, it seems like every team, they're producing predictive models, insights, all meant to drive decisions, right?
Yeah, it's everywhere.
But let's be honest. For every really brilliant data scientist out there, there are probably 10 reports just sitting, gathering dust, because they fail that really basic test. Communication. I mean, you could have the most complex, groundbreaking algorithm on the planet, but if the insight takes like 10 minutes just to figure out, well, it's not really an insight anymore, is it? It's just homework you're giving your audience.
That really is the core challenge, isn't it? You have to communicate these often highly complex results, things like predictive analytics, but do it efficiently.
Yeah.
And, compellingly.
Yeah.
The sources you share, they offer a really critical perspective on this. They basically tell us, look, stop obsessing over all the mechanics, the implementation details, the technical trees.
Right. The nitty-gritty.
Exactly. And start focusing entirely on the strategy, the big picture impact, the forest, as they put it.
Okay, so that's our mission for this deep dive then. We want to cut through all that noise. We're going to try and distill what the sources say are the 6 essential elements for making your data not just accurate, but actually influential.
Yeah, it's about impact.
And this isn't really about which charting software you use, right? It's strategy. We're looking at, number 1, context matters. 2, visualization derives from data. 3, less is more. 4, hierarchy among data. 5, beauty counts. And 6, telling your story. That's quite a powerful framework, actually. We really need to unpack the why behind each one of those.
Precisely. And the foundation really is that first one. Context matters. That pretty much dictates everything that follows.
Right.
It means every report, every slide deck, every poster you create needs to be purpose-built, to think about a specific audience and have a clearly defined goal in mind.
And this is where I think analysts often stumble, myself included sometimes. We kind of love the process, don't we? We dive into the data exploration. We try dozens of different models, generate hundreds of charts maybe. We want to show our work, but the sources seem to caution pretty heavily against that.
They really do. You've got to make a clear distinction between that data exploration phase and the final communication phase.
Right. Different things.
Totally different. The temptation is huge. You want to share every iteration, every single metric, just to prove how diligent you were.
Yeah, look how much I did.
Exactly. But if your audience is, say, a senior decision maker, they probably don't care about the Python script details. They just want to know, okay, what do I do next and why should I trust this finding?
So you have to adapt, filter out the execution stuff they just don't need.
You must. Filter it ruthlessly sometimes.
And the key to that filtering, it sounds like, is the so what factor. You need a specific learning objective for whatever you're presenting.
Absolutely.
Like if the finding is sales dropped 15%, well, okay, that number on its own is kind of meaningless, right? You have to give it context, some basis for comparison.
Exactly. Was that 15% compared to last month, last year? The competitor average? Without that comparison, your audience just can't make an evidence-based decision. It's just a number floating there.
Okay, so context is king.
Pretty much. And if we sort of expand on that idea of focus, of knowing your goal, we immediately connect to these principles of emphasis. Like principle 4 is hierarchy among data.
Hierarchy. Okay, what does that mean practically?
It means you have to strategically draw your audience's attention, guide their eye to the most important points, the ones that really support your main conclusion. Because, let's face it, not all data points are created equal in a presentation.
Right, some things matter more for the specific story.
Precisely. And that leads directly into principle 5, beauty counts. Now, this isn't about making a chart look pretty just for, aesthetic reasons alone.
It's not just decoration.
No, visual appeal serves a real functional purpose. It uses things like color, contrast, layout, all to guide the eye towards the hierarchy you just set up. A visually clear, maybe even beautiful report. It establishes credibility almost instantly.
I see. So it helps people know exactly where to look for the main point.
Exactly. Think of it like intellectual architecture. You're using design elements not just to decorate, but to actually emphasize the structure of your argument.
Okay.
And once you've aligned the audience, right, that's context. You've filtered out the noise. You've established that visual emphasis using hierarchy and beauty. Then you arrive at principle 6, telling your story.
Bring it all together.
Yeah, the whole output, whatever it is, it needs to be integrated into a final narrative, a story that really emphasizes the core message, the recommendation you probably started thinking about way back in Principle 1.
Okay. That really sets up the strategic framework nicely. Now, let's get into maybe the harder part sometimes, the mechanics of actually achieving that clarity. Principle 3, less is more.
Yes, the
Yeah.
subtractive principle.
When we talk about reducing clutter, it's not just about making things look tidier, is it? The sources talk about reducing the audience's cognitive costs.
That's a critical term, yeah.
Yeah.
And maybe sounds a bit technical, but we should translate that. When we say cognitive cost, we basically mean the mental energy, the brain power the audience has to use up just to understand what they're looking at.
Right, just to figure out the chart itself.
Exactly. If they spend too much mental energy deciphering, like overlapping lines or confusing labels, or maybe a really busy background, they just have no energy left to think critically about your actual findings.
So we're literally trying to save our audience mental energy so they can focus on the conclusion, not the deciphering part.
That's the goal. Minimize the effort needed for understanding the visual, maximize the capacity for understanding the insight.
Okay, so how do we measure this idea of simplicity, of low cognitive cost?
Well, the sources introduce something called the data-ink ratio. It gives us a kind of measurable target for simplicity.
Data-ink ratio. Okay, sounds technical.
It does, but the concept is actually pretty straightforward. The data-ink ratio equals the amount of ink used just to represent the actual data, divided by the total amount of ink used to print the entire graphic.
Okay, so the goal is maximize the ink that's showing data and minimize everything else, the non-data ink.
Exactly right. Think of it this way. If you print your chart out, right, every single drop of ink on that page should ideally be contributing directly to showing a data point or maybe a necessary axis label.
And if it's not data?
It's not data, it's basically clutter. It's noise. And you need to subtract it. The sources actually provide a very practical step-by-step cleanup process that is, well, it's pure subtraction.
Okay, let's talk about that subtraction. What are the common things, the offenders that analysts really must remove to maximize that ratio?
Right. Start with the easy targets. First, get rid of the border around the chart, usually totally unnecessary.
Okay.
Then, aggressively clean up the grid lines. Grids can be helpful when you're doing the analysis, sure, but they are often really distracting in a final presentation.
Yeah, they can make it look busy.
Very busy. Then think about removing unnecessary visual anchors. Like, do you need tick marks on both axes? Do you need markers on every single data point on a line chart if the line itself shows a trend? Maybe not.
Right, simplify.
Simplify the axes, too. Do you really need 4 decimal places on your labels? Probably not for most audiences.
Good point.
And finally, get rid of things like background color fills. Simplify complex or redundant legends. Every unnecessary line, every extra shadow, it's just adding noise and lowering that data-ink ratio.
That shift from additive design, what can I add, to subtractive design, what can I remove, that feels really powerful.
It's a fundamental mindset shift.
Okay, now let's connect this to principle 2. Visualization derives from data. Subtraction for clarity is great, but it only really works if you chose the right type of graph to begin with, right?
Absolutely. Garbage in, garbage out, visually speaking.
And the simple starting rule that the sources give is use graphs instead of tables whenever possible, because visualizing trends is just faster for our brains than reading a column of numbers.
Definitely. But that's also where the pitfalls start. We have to talk about some complexity warnings, especially around scales on axes.
Yeah. Misleading charts.
It's so easy to manipulate the perception of how big a change is just by changing where the axis starts or ends, or maybe using nonlinear scales without really clear labeling. This is a super common way communication gets distorted, even if it's unintentional.
Okay, good warning. But what about the biggest warning the sources seem to share? It's about using multiple axes. They strongly recommend avoiding dual axes, or heaven forbid, triple axes.
Oh, the dreaded dual axis chart. Yeah.
I know. I get the problem, but sometimes analysts feel like that's the only way they can compare two really different scales, like sales volume in millions and profit margin as a percentage, maybe on the same timeline. How do you handle that without using dual axes?
That's a really common challenge. The fundamental problem with dual axes is that most reports, most ways we consume this information, it's on flat 2D media, right? A screen or paper.
Yeah.
So when you have 2 different y-axes, the reader has to constantly bounce their eye back and forth, mentally mapping one line to the axis on the left and a completely different line to the axis way over on the right.
Which increases that cognitive load we talked about.
Spikes it, exactly. A much better approach usually is to split the data, maybe into 2 separate smaller charts that you place side by side.
Okay.
Or, if the main goal really is comparison, think about normalizing the data first. Maybe convert both series to a common index starting at 100, or show percentage change from a baseline. Then they can share a single understandable y-axis.
So it forces you to actually synthesize the comparison point rather than just dumping the raw data together and making the audience do the work.
Precisely. You do the thinking up front.
That makes the audience's job way easier. And speaking of pitfalls, we should probably reiterate the source's advice. Use fewer pie charts.
Yes, please. Fewer pie charts.
They're just notoriously bad for comparing slices, especially if the slices are similarly sized, right?
Absolutely. Our visual system, our eyes and brains, we really struggle to judge areas or angles accurately. If you find yourself reaching for a pie chart, just pause and ask, would a simple horizontal bar chart showing the percentages be clear, especially if you have, say, more than 5 categories? The answer is almost always yes.
Okay, bar charts over pie charts. Got it. And if an analyst is feeling stuck, like, what is the best chart for this data? The source material offers some good practical advice there, too.
Yeah, they say don't reinvent the wheel. Check out existing curated resources like the Python Graph Gallery or the R Graph Gallery online.
Good to...
These galleries showcase tons of chart types that are not only, visually appealing, but crucially, they're proven to be effective and data-driven for specific kinds of data structures and communication goals. It's a great place for inspiration.
Okay, this is great. We've covered the core principles. Now let's try and bring this all together. Let's apply these principles to a very specific, high-stakes communication format that's really common in the field. The predictive analytics poster.
The poster session challenge, yes. This format is often used to, quickly showcase some really complex work, help you organize your ideas, and maybe most importantly, it's designed to encourage immediate interactive discussion with people walking by.
And this format, just by its nature, it immediately forces the analyst to adopt that less is more mindset, doesn't it? The design rules the sources talk about are incredibly strict. It's like a constraint that forces clarity.
That's exactly the point. Look at the structure rules they lay out. It must always be in columns, not rows, columns. And the flow has to be perfectly logical. You read from the top left down, then to the next column top down, like a newspaper.
Okay, standard flow.
And the content ratio rule is explicit and kind of brutal. 60% graphics, 40% text.
Wow, 60-40. That's a lot of visuals.
It is. And that ratio is tough for analysts like us who often want to document every single assumption. It forces you to synthesize whole paragraphs down into visual takeaways or really concise bullet points.
And the legibility rules seem even tighter. You need to be able to read this poster from about 3 feet away.
Yeah, roughly arm's length. They suggest things like body text around, say, 34 to 38 point font, and headings maybe 46 to 55 point.
That's huge font.
It is. But that constraint alone is a radical editing tool. If you realize you can only fit maybe 200 words total on the entire poster, well, every single word has to count. There's no room for fluff.
So these constraints, they're actually the real-world mechanism for putting less is more and reducing cognitive costs into practice.
Exactly right. You have to rely heavily on bullet points. You have to maximize those figures and charts that follow the principles we discussed. And white space, empty space becomes absolutely essential.
How so?
Well, white space acts as a visual break. It helps separate the sections clearly, reduces that feeling of clutter, and guides the reader's eye through the columnar flow. It's not wasted space, it's active design space.
That makes sense. And what if you have, truly vast amounts of technical detail, the underlying code, the full model specs, the trees we talked about filtering out earlier? Where does that go?
That's where you can leverage technology smartly. The sources suggest using a QR code somewhere discreetly on the poster.
Okay.
That QR code can then drive your interested audience members directly to maybe the full interactive dashboard, or the project webpage, or a detailed technical appendix document online. It keeps the poster clean, but provides the depth for those who want it.
Okay, so poster content organization. The sources outline a pretty clear narrative flow for this too, right?
They do. You generally need sections covering, first, the business problem. Why does this matter? Then, the analytics problem. Framing, how did you translate the business problem into a data problem? Then, your methodology, briefly, what did you do? Followed by model building and evaluation, the core technical part. And critically, ending with the business implication, the so what, again.
And within that model section, we need to make sure the predictive component is super clear, especially for an audience that understands this stuff. You need to state the model choice clearly. Was it, linear regression, random forests, neural networks, whatever?
Yes, be specific. And you absolutely must present the relevant performance metrics.
Right. But just listing the metrics isn't quite enough, is it?
No, this is where that brief, insightful commentary comes in. For example, just listing accuracy and AUC doesn't tell the whole story. You need to maybe add a sentence explaining why they matter for the business decision.
Okay, like what?
Well, accuracy is intuitive, sure, but in a predictive context, AUC, area under the curve, tells a crucial story about how well your model can distinguish between the positive and negative outcomes across all the different decision thresholds. That trade-off is often the actual insight the stakeholder needs to grasp.
Right, it's not just one number.
Exactly. Same for something like RMSE in a regression problem. It gives you a clear magnitude of the typical prediction error, but in real-world units that the business understands.
And there's one more section or aspect that seems to separate real understanding from just reporting the numbers, the critical thinking component.
Yes, the sources really emphasize this. You need to try and explain why the model performed the way it did, whether it was good or bad.
So, reflecting honestly on limitations.
Absolutely. Was the data set maybe a bit small? Were there potentially crucial variables missing that, could improve the prediction in the future? Being upfront and honest about those limitations actually builds credibility, doesn't weaken your work.
Okay, so wrapping up this application section then, we need to bring it back to that core narrative structure we built from the 6 principles.
Right. You start by presenting the real-world problem. Briefly connected to the business or maybe social impact, why should anyone care? And then you emphasize the value of your findings. How can stakeholders actually use these predictions or insights? Maybe to change a process or adjust a strategy? It's always driving towards that actionable value.
It's that relentless focus on value and the so what.
Exactly.
Okay, so if we kind of zoom back out and connect all these threads, the 3 main takeaways from our deep dive today, really distilled from the source material, seem pretty clear.
What do you reckon they are?
Well, first, context matters, period. You have to define your audience, define your goal, and tailor everything accordingly.
Couldn't agree more. Foundation.
Second, focus on the story. Highlight the insights, the ultimate value, not just the, complex journey you took to get there.
Yeah, outcome over process and communication.
And third, beauty and clarity are actually functional. They're not just nice-to-haves. You need to simplify your visuals, use hierarchy effectively, and remove every single unnecessary element to aggressively reduce that cognitive load on your audience.
Perfectly summarized.
Mm-hmm.
But there's maybe one final piece, a sort of non-visual principle that the sources really stress.
Oh, what's that?
It's practice.
Yeah.
That clarity and efficiency you work so hard to build into your visual aid. It shouldn't end when the poster's printed or the slides are done.
The delivery.
Exactly. The sources strongly emphasize that you need to prepare multiple elevator pitches using that perfect visual aid you just created. Specifically, they recommend practicing a 30-second pitch, a 90-second pitch, and a full 2-minute pitch.
Wow, 3 different versions for the same work. That's forcing you to create 3 completely distinct narratives, really, for a single body of work.
It is. Different levels of detail, different points of emphasis, depending on how much time you have.
Okay, so here's maybe the final provocative thought for you, the listener, to mull over then. If your predictive analytics poster or your report is visually flawless, it nails the 60-40 ratio, it has perfect data Inc. standards, everything, but you cannot actually deliver the core story and the main conclusion in 30 seconds.
Yeah.
Did you really reduce the cognitive load for your audience effectively? What are the profound implications of preparing 3 distinct timed narratives for the exact same piece of work before you ever step in front of a stakeholder?
Mm-hmm.
It kind of suggests that communication isn't just an output like the poster itself. Maybe it's more like a performance.
Yeah, that's a fascinating way to put it. The visual is the stage, but you still need to deliver the lines perfectly. Food for thought, indeed.